Okay, in this video I'd like to discuss the atomic and nuclear masses. So this video leads on from my video on the fundamentals of nuclear physics, which I suggest you watch. And what I said in that video was that you have, if you were to name an element, we'll say any element, and we'll say X was just the general element on your periodic table. It could be carbon, it could be oxygen, it could be silicon, and we'll say X. And X has some protons, some neutrons, and and has electrons. So we write this by saying the following. So if the Z is the number of protons, N is the number of neutrons, and A is the total number of nucleons. So we say a nucleon, N-U-C-L-E-O-N, is the total number of protons. Oh, let's take that back. A nucleon is either a proton or a neutron. Okay, these are the particles which make up an atom, or a nucleus, excuse me. That's why we call them nucleons. So there are two nucleons. So Z for protons, that's the total number of protons, N for neutrons, and A is the total number of nucleons. So that means that A is equal to Z plus N, the total number of nucleons, the amount of particles in the nucleus of an atom, which is the total number of protons plus the total number of neutrons. Alright, so that's just a small bit of notation. So what if we want to get the mass of a neutron, or excuse, take that back, the mass of a nucleus? So we write this, M is usually what we use for mass, and if it's got a small subscript n, we're talking about the mass of a nucleus. So what would you suggest, what would you think the mass of a nucleus is? Considering that we said the total number of nucleons A is equal to the total number of protons plus the total number of neutrons. Well, then you'd say, you would probably think that it's equal to the total number of protons times the mass of times the mass of a proton plus the total number of neutrons times the mass of a neutron. And if you were to say that, you would be incorrect, because in actual fact the mass of the nucleus is less than the mass of all the protons and the mass of all the neutrons. And you might say, well, hold on a sec, that sounds absolutely crazy. Well, think about this. The charge on a proton is plus. The charge on a neutron is negative, or not negative, zero. It doesn't have any charge. And we know that like charges repel, unlike charges attract. So what we're trying to do is pack all these positively charged particles with these negatively charged, or these neutral charges, which they don't matter, into a small space, a really compact space. And they don't want to do that. They want to blow up. They want to go everywhere. So in order to keep them together, you need to expend energy. Alright? You need to expend energy. And what happens is, some of the mass is converted into energy. So everybody has heard, I'm assuming, of the formula E is equal to m times c squared. And that means that mass and energy are the same. So the only difference is this multiplication of the speed of light squared. So that means that you can get a mass by dividing an energy by c squared. That's a mass. Alright, that's a mass. So what we're saying here is that the mass of the nucleus, okay, is less than the mass of all the neutrons and protons, which separately, because some of this mass energy had to be converted into energy. So we need to reduce the mass of all these by a factor of b over c squared. Okay, where I'm saying b is like a binding energy. You can say e over c squared. So it's a mass. And if you do that, then you have the mass of the nucleus is equal to the mass of all the protons, or the mass of all the protons plus the mass of all the neutrons minus the energy to keep all the protons together. Okay, and this is a mass because it's energy divided by c squared. So that's the mass of a nucleus. So the next thing I'd like to discuss is the mass of the atom itself. So why did I rub that out? Because I'm going using it. So we had A, we had Z, and we had N. Now an atom must be electrically neutral. It must be electrically neutral. So what particle have I left out in the discussion so far? And the answer is the electron, which is negatively charged. So how do we take into account the electrons? Well, the electrons aren't in the nucleus. The electrons are orbiting the nucleus. So look, if we look at the Bohr model, and I'm not saying that this is correct or this is the current model, but one of the models, the Bohr model, says you have all these, a nucleus, a spherically symmetric nucleus, packed with all these neutrons and protons, and orbiting that you have these electrons. Alright, So when I said I was talking about the mass of the nucleus, well then there are no electrons there, so we couldn't talk about the electrons. But in order for us to have an electrically neutral atom, then we must have the same number of negative charge for the electrons as we do as positive charge. That means the number of electrons is equal to the number of protons. But what letter do we use for the number of protons? And that is Z. Therefore the number of electrons is also equal to Z. Alright, of course the charge is different. So let's take into account the mass of the whole nucleus. Okay, so or the whole atom, the mass of the atom, which we say is just m. Okay, so you'd think, of course, it's going to be the number of protons times the mass of the proton, plus the number of neutrons times the mass of the neutron, plus the number of electrons times the mass of an electron. And for the same reason I said a moment ago, in actual fact, if you just do that, you have all of these being of greater mass than when they're put together, for the same reason that we need to expend energy to keep them together. So that means the energy we need to do, of course, we had a moment ago was this binding energy here, capital B over c squared, or this mass, so B over c squared is a mass, the binding mass. But this is the binding mass for the nucleus. And we need to also bind in the electrons, so we have a small b for that. And this is a mass as well. And when you do that, you have the mass of the total atom. And another way of writing that is just that m is equal to m sub n, the mass of the nucleus, plus z times me, plus z times me minus b over c squared. So this z times me is the mass of the electrons, and we need to, we'll say, correct for this energy, or this mass being converted into energy in order to keep the atom together. Alright, so I think that's all I've got to say about that. Yeah, I think that's all I've got to say about that. So thanks for watching. Please pass it on to your friends and subscribe to my channel.